Kat.
So, we've heard how thermoelectric generators, or TEGs, could be a useful way to turn waste heat energy back into useful electricity in small-scale settings like cars and things like that. But there are also settings on the very big scale, for example, like a power station, which throws away huge amounts of heat up its cooling tower. So, could thermoelectric technology help here? Now, we're going to talk now to Andrew Knox. He's Professor of Power Electronics, Renewable and Sustainable Energy at Glasgow University, and he's looking at the feasibility of using this kind of technology, but more or less in reverse. So, good evening, Andrew.
Good evening, Kat.
So, tell me a little bit about, for a start, the kind of scale of heat loss we're talking about in a power station and why it would be attractive to try and use thermoelectric technology.
Much of the UK's power generation comes from what's called thermal power stations, and that's whereabouts we burn fossil fuels, gas, coal, etc. And the generation of electricity from that process is subject to various thermodynamic restrictions. And it's the same basic problem that the thermoelectrics have got, where you've got a hot and a cold side, and the maximum efficiency is a function of those as determined by the Carnot cycle. In a conventional thermal power station, typically what happens is you burn the fuel, let's say coal for example, that raises steam in a boiler. That steam is then routed through a turbine, and the force of the steam going through the turbine turns an electrical alternator, which is what generates electricity. The steam goes through a series of different turbines, each at progressively lower pressures, and at the end of that process, when you've extracted about as much of the useful work as you can out of the steam, what you have to do is recondense the steam back into water, and that water is then returned to the boiler to be used again. And the water that's used for this as the working fluid for this power generation process is exceptionally pure. And the reason for that is that any impurities that would be in the normal tap water, for example, would convert your turbines into Swiss cheese very quickly. I mean, it would really attack the turbine blades. So this process that's going on of boiling water, driving it through a turbine, and then condensing it back to water and reboiling it back in the boiler, that process is called the Rankine cycle, and it's subject to limitations. Now, if you drive past a large thermal power station, let's take, for example, Ferrybridge down the M1, which is a sort of fairly well-known route. When it's working, you will see large quantities of steam being rejected from the cooling towers. And the cooling towers are these big, huge concrete structures. And that's basically dropping the energy out of the steam back to the environment. So that's wasted heat. And on the best modern thermal power stations, their efficiency is about 47%. So more than half of the energy that's used is being rejected to the environment.